Okay, so here we actually get to see it in long division, and you can see that it definitely gets a little kooky, right? So you definitely have to keep track of your variables. You have to make sure that you're combining like terms. You still have to account for any missing variables, as you see right here. So we had on the left side x cubed minus 8 divided by x minus 2. So look, they still account for those missing powers, the x squared and the x to the first. And then it just gets super messy. So when you can use synthetic division, go for it. Okay, here we go. So I look at my denominator and I'm like, okay, that's a linear factor, so I can go ahead and use synthetic division. I'm going to set this equal to 0. And I get x equals 1. That's going to go in my pocket. Okay, then I look at my numerator and I'm like, okay, I'm definitely missing some powers, some exponents. They're skipping a couple. They are in descending order, but it's skipping a couple. So let me go ahead and rewrite that. So I have x to the 5th. I do not have an x to the 4th, so I'm going to add plus 0x to the 4th. I do have an x cubed, so plus 10x cubed. I do not have an x squared, so plus 0x squared. I do not have a x, so plus 0x, and then minus 11. So adding quite a few there. And then I always check it again, x to the 5th, plus 0x to the 4th, plus 10x cubed, plus 0x squared, plus 0x minus 11. Okay, so that works. So now let me go ahead and get my coefficients. I have 1, 0, positive 10, 0, 0, and negative 11. All right, we're ready to go. So drop that first one down. Multiply. 1 times 1 is 1. We add 0 plus 1 is 1. Multiply. 1 times 1 is 1. Add. 10 plus 1 is 11. 1 times 11 is 11. 0 plus 11 is 11. 1 times 11 is 11. Lots of ones here. 0 plus 11 is 11. 1 times 11 is 11, and then negative 11 plus 11 is 0. Okay? We are starting 1 power less than what was in our numerator, so x to the 4th. So we have 1x to the 4th plus 1x cubed plus 11x squared plus 11x plus 11, and then our remainder was plus 0 over our original denominator, x minus 1. Because it's 0, right? If I say and 0 thirds, then I can just leave that off, right? I wouldn't say, oh yeah, I remember I owe you $5. I mean, I guess I could say in 0 cents, but I could easily say, oh, I owe you $5 and just leave that and 0 cents off, right? It's understood that, okay, there's nothing past that $5. So in this case, we just leave that off. Unless my math lab asks for it. Sometimes they will have it where there's a box for the remainder, specifically for the remainder. And so yes, you would have to put 0 in there because they're saying, okay, well, how much of that remainder is there? Well, if it's 0, then you would put a 0 in there. But if not, you can just put that in as your answer. Okay, so this one has a fraction. Sometimes that freaks people out. Do not let fractions freak you out, okay? It's still a value, and you're just going to take the same approach that you took before. You just now have a fraction in the mix, but do not let that freak you out. So this x minus 1 1/2, I'm going to go ahead and set that equal to 0. and I get x equals 1/2. So that number is going in my pocket. Okay. And then we look at the numbers in our numerator. So 8x cubed plus 2x squared minus 5x plus 1. Look at the integers, right? Making sure first that my powers are not skipping and they're in descending order. So they are indeed in descending order, and I'm not missing any, right? I have 3, 2, 1, and then none. So that works. So now I can take my coefficients 8, 2, -5, and 1. And I'm ready to go. Okay, so drop that first number, 8. 1/2 times 8, you can punch that into your calculator, so don't get flustered with fractions. That sounds like it would be a video. Don't get flustered with fractions. Just go ahead and punch it into your calculator and let it calculate for you. But 1/2 times 8 is 4. 2 plus 4 is 6. 1/2 times 6 is 3. -5 plus 3 is -2. 1/2 times -2 is -1, and then 1 minus 1 is 0. Okay? So starting with 1 power below what was in our numerator, so we had x cubed as our leading coefficient, so we'll have x squared, and then just fill it in descending order. And then we had no remainder, right? If they asked for it, then we'd put 0 in there, but if not, that would be our answer. And what I mean by if they ask for it, sometimes you'll see in my math lab something like this. And they'll already have the divisor right there. So that's what you would have to put a 0 in there, right? You don't want to leave it blank. So you'd say, okay, there's no remainder. So if divisor is included, then go ahead and put the 0 in there. Okay, so we can use synthetic division in something that we call the remainder theorem. Okay, so basically, and you also have done this before, you've just taken a different approach. So if they give us the function p of x equals x cubed plus 4x squared minus 5x plus 2, and then they give us an x value of 2, then we would just plug and chug, right? We basically just plug that 2 in every place that we see an x, and then calculate it, right? So that's what we've been doing before. Well, now they're saying, hey, look, you can use synthetic division and come out with that same value depending on whatever your remainder is. So let me show you, because explaining it just sounds crazy. So here's the thing I don't want you to get confused on. This number right here, when they give it to you, do not try to say, oh, I have to set it equal to 0. So we saw in all of these ones back here, right? We ended up getting, it feels like the opposite, because we set it equal to 0, and then we had to basically undo it on both sides. But we keep seeing that, look, it's x minus 2, and we got a positive 2. It was x minus 1, and we got a positive 1. It was x minus 1/2, and we got a positive 1/2, right? So a lot of times the students, they just get set in saying, oh, it's the opposite, it's the opposite. Well, be careful, because when they give you this number, that goes directly in the pocket. There's no taking the opposite of that, okay? Then we would look at the function that's given, and we would do the same thing we did before with the numerator. We would make sure that we're not missing any powers in that descending order, and then also making sure that it's in the descending order. it is in descending order. It is not missing any of the powers. And so we're going to go ahead and take the coefficients. We have 1, 4, -5, and 2. And then we go ahead and do the synthetic division. So drop that first number. 2 times 1 is 2. Add. 2 times 6 is 12. Add. 2 times 7 is 14. Add. And here's the part that you'll want to pay attention to, because I've had students who want to write out that entire bottom row, but when they mention remainder theorem, think I'm only concerned about the remainder. So your answer would only be 16. I like to look for clue words in questions and just the verbiage of it, because sometimes it can be confusing when you're trying to get all of this information and wrap your head around the information and around the words being used, and well, when do I use this approach and when do I use the other? So if you see remainder theorem and you know, okay, now I'm going to use synthetic division, but I'm only worried about my remainder when I'm using the remainder theorem, okay? Let's try this again. So they give me p of x equals 3x cubed minus 3x squared minus 7x plus 3. And then they give us a value of -2. Now, could I just take that number and plug it into my calculator into this function? Absolutely. That's a great way to check it. So I would definitely check it that way, just in case my math went wonky anywhere. This is the number that's going in. That was supposed to be an arrow. My pocket. Then I look at my function, all the coefficients that I'm going to write down. Before I do that, I need to make sure that all of my powers are in descending order and I'm not skipping any. 3, 2, 1, and none. Good. So 3, -3, -7, and 3 are the values I'm writing down. And then we're ready to go. Drop that 3. Multiply. -2 times 3 is -6. -3 minus 6 is -9. -2 times -9 is a positive 18. Add -7 and 18 will give me a positive 11. And then -2 times 11 is a -22. And add it together, that gives me a -19. Because they mentioned the remainder theorem, I know that that is the only thing I'm worried about, my remainder. So -19 would be my answer. So let's go ahead and check that with the calculator. If I was to set it up in my calculator, I would say, okay, 3 times 2 cubed minus 3 times 2, oops, -2. -2, I'm getting this -2 from this number right here. -2 squared minus 7 times -2 plus 3. And voila, that's it entered into the calculator. And sure enough, we get -19. Okay, another way that we will use synthetic division is finding zeros. So when I have a zero, remember the different names that we use for zeros. We can say zeros, x-intercepts, solutions, roots, right? But when we find a zero, we know that that zero has to divide into that function, okay? So in this one, they give us the equation x cubed plus 2x squared minus 5x minus 6 equals 0. And then they tell us that 2 is one of the zeros. So 2 is one of the solutions. So because they give us that number, again, I'm not going to do anything because they already told me what x is equal to, right? 2. So I just plug that straight into my pocket. And then I do what I did before. I take my function and I look at the powers. They're in descending order. So 3, 2, 1, and none. And I'm like, okay, they're in descending order. There's none missing, so I can go ahead and take the coefficients. 1, 2, -5, and -6. 1, 2, -5, and -6. So drop this first number, multiply, add, multiply, add, multiply, add. The remainder has to be a 0 if this is truly a solution. Remainder must be 0. If I was to get any other value there besides 0, and they told me that 2 is a solution, then I would have to go back and check my math, because that means that 2 wasn't a solution if that remainder was truly anything besides 0. Okay, but now look, now we have a quadratic equation, and with a quadratic equation, I can factor it, I can use the quadratic formula, and so now I have a couple options to find the other two solutions. So in these situations, when they give you a function and they're saying, okay, find the zeros, and this is one of the zeros, then you will take that 0 to basically like chip it down to a quadratic function so that you can use the quadratic formula or factor it out. So let's go ahead and factor this. And then if I set each of these equal to 0, I would get x equals -3 and x equals -1. When you go back to write the solution set, don't forget about the 0 that they gave you. Some students are like, yes, I got to the answer, and then they write -3 and -1 in, and they're super disappointed when they get it wrong, but it's because they missed that given 0. So 2, -3, and -1. And so basically, we had x cubed plus 2x squared minus 5x minus 6 equals 0, completely factored out. So we were given 2 as one of the solutions, right? So that would have came from x minus 2, and then we had x plus 3 and x plus 1. And so this is where we get all our answers from. Okay, one last one. They give us the answer there, but that's okay. We're going to see how we actually get there. So they tell me that one of the zeros is -1. They give me the function x cubed minus 5x squared plus 2x plus 8. And I see that I have all my powers in descending order, and I also am not missing any. So I'll take that -1, put it in my pocket, and then the coefficients from that function: 1, -5, 2, and 8. Have it set up, drop that first number, 1, then multiply -1 times 1 is -1, add, -5 plus -1 is -6, multiply, -1 times -6 is +6, add, 2 plus 6 is 8, and then -1 times 8 is -8. Okay? Remember, that has to be a 0. So yes, that confirms that this is one of the solutions because my remainder is a 0. This now takes me to the quadratic equation x squared minus 6x plus 8 equals 0. I'm going to factor that. X minus 4, x minus 2. And when I set each of those to 0, I get x equals +2 and x equals +4. Remember that -1 was the 0 that was given. So my solution set is -1, +4, and +2. And just to show you, this equation was just these factors all set equal to 0. And so that's how we got x equals -1, which was our given one, x equals 4, and x equals 2.